The first thing that I'm going to work out is angle A. But do you know what I see? I see that A forms an angle between a tangent and a chord. And I'm going to use my red Koki for the people who's battling. Look, there's your tangent. Remember the second theorem I showed you? And there is your chord. So that A is an angle between a tangent and a chord. Now go look for a triangle that goes to the circumference where you use your chord. Can you see that I'm using that triangle there? There and there. So the student who sent in that it's 41, what do you say now? Can it be 41? The answer is no, it can't. So I have that A is equal to 29. Beautiful to the students who sent that in. And I used angle between a tangent and a chord. So for this reason, matrix, you can just write tan chord. You don't have to give the name of the tangent and you don't have to give the name of the chord. But look what I do, grade 12s. The minute I have the size of angle A, I put it on my sketch because it might help me for my next question. Angle A is 29. Come on, everyone. What do you say is the size of angle B? What do you say is the size of angle B? So we're looking for angle B. And here B is here. So what I did for B, I saw that this angle plus B plus the 29 lies on a straight line. So I just said B is 180 minus 75. Do you agree with me? Minus the 29. And there we go. A lot of you are sending in that B is equal to 76 degrees. And what do you say is your reason there? The person that sent in. What do you say? B 76. Give me the reason. Angles on a straight line. Fantastic. What do I do with my 76 grade 12? I put it on my sketch because it might help me. Let's go to angle number C. I'm looking for C. Now what I did was to find the size of angle C. I said this angle here is 34 degrees. Do you remember the theorem? I'm going to draw it quickly for you. Angles in the same circle segment. Remember, I say this is the bunny ears theorem. That angle there is equal to that angle there. And this angle here is equal to that angle there, subtended by that segment and that circle segment there. So am I correct when I say that this angle here is 34 degrees? This angle doesn't have a label. It doesn't have a 1, a 2, or a 3. So I'm going to call it angle QPR. This is to find C. So I'm going to say angle QPR is equal to 34. Can we just get our reasons right this afternoon? Angles in the same circle segment. Some people just say angles in the same segment, circle segment. That is fine. You put your 34 there, grade 12s. Now remember, they told you that this angle is 75. So angle C, what will angle C be? 75 minus the 34. So angle C is 75 minus 34, and that gives you 41 degrees. Are you happy with that? From there is 75, but that little angle there is 34, so C must be 41. And we go to our very last question for this sum, and this sum is, what is the size of D? So let me just see, I've got there B76, that's beautiful. Let me just see if people got that C is equal to 41. Fantastic. That is so nice. And then the last question here is to find D. And we used it. Remember, we said the exterior angle of a cyclic quadrilateral is equal to the opposite interior angle. So I need to find the size of Q1 first. So I'm going to say Q1. What do you say is the size of Q1 matrix? Q1 is equal to 76. Angles in the same segment. angles in same segment. And then we can say this is then 76, and then D would be equal to, what do you say, 29 plus 76, and that is absolutely fantastic. There's somebody that sent in that D is 70. Just look again, it can't be 70 because this is your exterior angle will be the 29 plus the 76. Do you get that? And that's beautiful. People are sending in that is 105. So D is equal to 105. Can we get our reason right? Exterior angle of a cyclic quad equal to the opposite interior angle. Abbreviate your answers. You don't have time in the exam to write all of this out. Exterior angle of cyclic quad is equal to the opposite interior angle. And well done. People are sending in such beautiful answers. I'm so proud of you, grade 12s. You are really participating, and that makes me very, very happy. Are you ready for the third sum? So I've got question 3 now. Can we just look? Question 1, we basically use theorem 1 and Pythagoras. In sum number 2, we used the bunny ears. We used the tangent chord. Look for a triangle. We use that a lot. We use angles on a straight line. And then one last thing we did for D, we used the exterior angle is equal to the opposite interior angle. Okay. Now, I know it's going to be a little bit difficult for you to send through answers here because there's a lot of show and proof. But what I want you to try and do at your schools, even if you can't send me through the answers, it's all right because it's difficult to send through a whole proof or a show. Why don't you sit there at your desk with a friend or by yourself and you try and work out the sum by yourself, because remember, geometry is you have to see it. You have to see it, and you can just confirm with your friend if they see it as well. And as I work through the sum, you just see if your sum is correct. Will you try that? So don't chat and listen to the production this afternoon, because I really, really want you to start loving geometry